I go to the Norway, and I go to videos and live, and getting there, and public live, and I need to edit it so that it's Swen303. Swen303 from VR. Save. Now, I just need to share that link with you. And so that is, yes, it's me. So video URL, right, okay, copy. So I'm putting this into the Discord channel. And the link in the Discord channel is, yes, I was doing the present and it wasn't thing, but that link should be me streaming live on YouTube. Is that link? Excellent. Okay, so you might want to mute the Discord on the lecture theatre so you don't get my audio twice. Okay, can you hear my audio? I'll look at the Discord chat if anybody wants to send. Yes, we are receiving video. Okay, so I'll assume you're receiving video in the lecture theatre. Right, okay, so now we've got that set up and I'm streaming and you can see me in Auckland. This is the remote version of me. This was an unplanned thing because, as you can imagine, the weather in Wellington has delayed me. So I can't actually be with you there at the moment. So what I was going to do is I was going to try giving this lecture remotely. Now, if I just move that over there, that should work. Right, okay, so that keeps me there, that keeps me there. I'm all good. Now I can see any comments. So if you have any comments, type them into Discord. We'll do the questions that way. Okay, so the lecture today was supposed to be me down the front of the stage in a VR headset. Now, if I'd known this was going to happen, I would have brought the VR headset with me and I would be in Auckland in my VR headset and I would have set you guys up in Wellington as my remote students and had one of you borrow a VR headset and be in VR and kind of show people what you were seeing. Unfortunately, I've run out of a chance to do that. So I was going to give you the talk about VR and the kind of some of the challenges and some of the interesting user interface issues around VR. And we'll just have to show you real-time me doing VR stuff in another lecture. So this is on AR and VR. Okay, so this is moving into a post-screen in the world kind of, these kind of devices and this kind of laptop that I'm looking at, moving beyond that and saying, well, if we strap one of these screens to our face, how do we see the world? If we overlay glasses with information, how does that change the way we see the world? Now, Microsoft put a massive amount of effort into gearing up for augmented reality. In fact, Windows 10 itself treated AR interfaces as a core component. They felt that AR was going to be so important that they decided that was going to be core to all new experiences in the Microsoft operating system. So you get this kind of core development of new systems, recognizing that AR and VR are where we are going. The HoloLens came out. It was supposed to be a consumer device. They realized that consumers weren't ready for it yet. And so the HoloLens 2 came out at the beginning of this year, and it's focused at industry first because it's going to solve problems for industry. And once that's working, then they're going to roll out a consumer version. Magic Leap is trying to do consumer version augmented reality. Now, that, as Stuart was talking about novel interfaces, this AR, VR stuff is very novel, right? So we've got very new interfaces. Now, a standard VR interface is this sort of one where you have kind of large screens that pop up in your VR experience. And, you can look around, you use controllers to select things, or you use gaze where you're looking to select things. If we go to something kind of more sci-fi, we could actually start looking at pretending that the user is in a helmet, so that when you look around the world, the HUD is as if you're wearing a helmet, and so this is just the eyepiece looking through a helmet, and the helmet has HUD information, VR information on it, and you look around the VR world, and you get all this additional HUD. Now, that's one of the things we're interested in terms of interfaces in VR, is where do you put information? Because one of those big challenges is once you're in the virtual world, having this type of interface pop up in front of you could be a significant distractor from being immersed, being deep in the world. And so that's one of the things that we're looking like. We have to work out as a UX community, what should UX look like in VR? Should it be this kind of things out in the world? Should it be this close to my face HUD? Should it be no HUD at all and be this sort of video where I see VR environments? Oh, that's going to be quite loud. Okay, I can't control the sound of that because I can't get to the controller because Google is overlaying things. But so okay, right. Sorry. Every time I tried to move my mouse pointer over the pause or the volume of that video, it would pop up the Google Slides interface over top. So press up key. Excellent. Thank you, Sean. I did get there. So yeah. So in this VR experience, and what you can see there is I don't really have a HUD. All the information is in the world, and I can see other users. Now, this is the sort of thing that I've been doing from VR into Norway, and I've been teaching in this VR experience where we don't have a HUD as such. All the information is in the world, right? And so that's one of those the big changes, saying, well, we won't have a HUD. We will have information on your hands, right? So when you hold the controllers, you get information on your hands rather than in the world, right? Now, I'd be able to show you that if I was in VR, but at the moment I'm not, so I'm just having to show you some videos. So if, that scoots along, but here you can see that the slider, they've got a controller that they can use, and so it's not a HUD, it's an element in the world. So everything you're interacting with is in the world. We also have, this is some of the early Magic Leap videos, and so if I press play on that, so okay, so if I get to the actual part of that they're using, so this talks a wee bit here about Okay, so hopefully you guys can hear that when he's talking. Can you hear it when he's talking? I don't know if you can, but hopefully you can. Desktop audio isn't captured, by the way. Right, just my mic. Okay, so you just hear me talking. Okay. I can turn on desktop audio in my audio settings here, and desktop audio. I'll bring that up. And hopefully now...
All right, second.
With you. Of standalone headsets that offers 6 degrees of freedom. So what's so special about the Quest?
We think that there are a few key qualities that any VR system that gets to scale needs to have. So first, it needs to be standalone. It's that way there are no wires. All right, second, it's got to support hands. And third, it has to offer 6 degrees of freedom.
Oculus think that full hand tracking is a secret weapon that puts the Quest above the rest. So what do those extra degrees of freedom?
Okay, so hopefully I was able to work out how to get the desktop audio working. So the Quest, which actually came out last week, so this is them talking about it earlier at the end of last year, but the Quest has just been released. People are now using it. It's about $500 US. It's got very good reviews from a bunch of people. It is 6 degrees of freedom and the full VR experience. Now, so when we talk about the Quest, there are many choices. As they just said in the video, there are lots of these devices. Hand tracking is something that Oculus believes that it can do better than anyone else. But the Oculus Quest, one of the compromises it makes to make it run without having to plug it into a laptop like this big heavy laptop that I have is that its graphics aren't as good as the HTC Vive. Or that should not be Pimax, that should be Pimax. But yeah, so it's not quite as good as the Pimax is kind of 2 4K screens, one for each eye. So massive resolution. You need a 2070 or better to run the full 8K, 2 times 4K screens. So so there are some VR makers who have gone down massively high end. The Insight from Valve is again a massively high end, high resolution, lots of display. The Oculus Quest has gone the other way, lower resolution, but can be worn entirely on your head. It only gives you 2-hour battery life, so it's not great for long experiences, but it fits on your head. You've got your hands, you're in and you go. You have no setup. Now, what I was going to show you here was actually the setup with lighthouses and the full Vive setup. One of the neat things about VR is this is not one company that is trying to push VR and no one else is interested. There are lots and lots of choices around which VR system to use. Now, that's good and bad. It's good that there is competition, and so we expect these to improve quite rapidly. It's bad because you have to adjust to different suppliers. So the Quest is different to the Vive, which is different to the PlayStation VR, which is different to Pimax, which is different to Valve Insight, and so on and so on. So building a single interface becomes challenging, and that's what we're thinking about. What is the interface to all of these? What do I actually do? What do my hands do? Now, what they're talking about with the Quest there was 6 degrees of freedom. Now, what I mean by 6 degrees of freedom, and what is meant by 6 degrees of freedom, is that when you look at my head, I have 3 degrees of freedom. If I go 1, which is yaw, 1, which is roll, and 1, which is tilt. Right, so that's me looking around, looking up and down, and rolling my head side to side. So those are the first 3 degrees. The other 3 are being able to translate sideways, so being able to strafe, and going up and down, and going in, out, and in. Right, so those are the other 3 dimensions. So normal X, Y, and Z are 3 dimensions, and then roll, pitch, and yaw are the other 3. So that gives us 6. One of the things that makes you sick in VR, if you tried some of the early VR, is if I'm here and I move my head and the world doesn't move, my body goes, oh, wait a minute, you've eaten some poison. Somehow your eyes are not doing what your body thinks are doing, and that usually happens because I've eaten some magic mushrooms, I'm now having hallucinations, I should get whatever poison I put in my body out of my body. And so we tend to vomit. And so the body responds badly to that mismatch, that visual mismatch, because evolutionary in our history, that visual mismatch was related to having eaten things I shouldn't have eaten. Now, this getting to a stage where we're able to keep that visual fidelity, keep that tracking at such a rate that as I move, the world seems to stay locked as a solid object in the world and doesn't slosh around, right? Because the real problem with VR sickness and motion sickness is usually that I move my head and the world sloshes into place. And I move my head and then the world sloshes into place. And that feels terrible. And so we're just getting to the point where VR starts getting over that barrier. You'll now are much less likely to feel those VR sickness issues. Now, as an interfaces designer, so we've got these hands, we've got controllers in the world. One of the things we're interested in with interfaces is how we do text. So what should text look like in the virtual world? And this is when we start talking about, what are the conceptual virtual screens that we're talking about? Because when I go back to this early one here, how big should the text on those borders be? Okay? How big should the text in this HUD be? What should it look like? This is mostly white text on a black background. But what I do if I'm in a VR environment and suddenly, the sun comes out and now it's white, all of this white text would just disappear. So it's kind of, I've got to know what's behind it to know what color it should be. And what if half of it is white and half of it's black? Do I have to change the font color on half of what I'm displaying so it starts off black and then comes in white? It's halfway through. It's, what do I do? So yeah, for all of this, you need to work out, how should we display text? How big should it be? What should it look like? So one of the things to think about when you've got your little headset, and you can see the little headset in the bottom corner there, is if I've got something close, I've got a letter A, and it's up right by my headset. And then, at about 30 centimeters, I could have the equivalent of a mobile phone held here, which is, the distance we normally look at a mobile phone. And so I can have letters and text at that size. But then in the virtual world, I'm also displaying things at a meter, and I'm displaying things at 10 meters, and I'm displaying things out in the world. And so one of the things to think about is how much that text grows and shrinks in those different viewing conditions from the VR environment. And so when I look at a VR interface and I hold a virtual phone up to look at it in the VR headset, how big should that text be, and should it blur as it goes further away? Should I have this idea of depth of field? Now, if any of you have an opportunity, one of my PhD students, Kieran Carnegie, Kieran is running an experiment on how to deal with this specific problem in VR. So this is active research. How do you deal with depth of field? That the thing close to me is in focus and the thing far away of me is out of focus. And so his experiment, and he's running it currently, so you can sign up for it and you go up in the psychology department and trial his VR thing. So if any of you are interested, please drop a line in the Discord and I'll get you in contact with Kieran, and you can go and try the VR environment that he has and try this depth of field issue. Now, he's not using text, he's just using general images depth of field. But as an interface designer, you're required to think about how do I display interfaces? Should I have this depth of field? Should I have this blurriness? Should it be close to my face? Should it be on the world? Should it be out in the world? And I have all of these kind of issues around normal rules that we have around, how big should a headline be? And, normally I'd talk about pixels, right? Or I'd talk about so you'd use pixels, or you'd use EM for the size of the M character, of point sizes. So, you guys are used to setting things at 12-point font size. Well, 12 point makes sense when you've got a screen and you kind of have a piece of paper and a 12 point is a known size. But in VR, I can move my head closer to things and further away. And has reconnected successfully. Okay. Sorry. I went off here 10 minutes ago. Still working in lecture. Okay. So it was still working. Try refreshing page. All right, it's back for me. Back now. Okay. So it told me it disconnected and reconnected anyway. So we'll keep going. You guys pop in the Discord and tell me if things break. So that text size, you can't use normal point sizes like 12-point font and 10-point font and 8-point font anymore, because that text size becomes a problem. And so what they're looking at in terms of interface design in virtual reality interfaces is actually going back to saying, okay, what we mean by text size is no longer a 12-point font. We talk about how much angle, right? So the density of pixels, right? So there's these depth millimeters, right? So it's this combination of how far away it is and how much space it takes up, right? So when we talk about the interfaces, we need a new metric. And so instead of just being millimeters, you need this depth and millimeter combination, right? So at 1 unit of depth, how many millimeters is it taking up, right? So 1 unit from the headset, how big it is. And so the idea is that you now use new measures when you're designing the interface. And so as interface designers, this is the sort of thing we have to do in VR. We also have to think about the ergonomics of VR interfaces. And by ergonomics, we mean, how I move my eyes around when I'm looking at the world and how I move my head around when I look in the world. There are some very interesting things in VR, and if you do Kieran's experiment, interesting things about how when in normal situations you tend to look around with your eyes quite a lot, but once you're enclosed in the VR headset and you've got the small window you're looking at, you have to kind of move your head more because the outside's a bit blurry, and so you move your head around to look at the world, which changes a bunch of the natural interactions. We also have to think, what do I do with these hand controllers? How smooth are they? How big are they? The Vive controllers that I have are different to the Oculus controllers, and you can do different things with them. One of the other things I have is the Leap Motion, which actually tracks fingers. And so one of the interfaces that I'll show you once I'm back and able to show you some of the VR stuff is how you can have your hands in VR and actually see your real fingers doing things. And that's again ties you closely into the virtual world. But we also have to worry about how good is the tracking, how large is the area I'm in, and is there visual mismatch between where the system thinks my hands are and where my actual hands are. And so when I try and clink the controllers together, is there a mismatch between the real world and the virtual world? Now, we have in Wellington a special connection to Magic Leap because a subdivision of Weta has been working on Magic Leap, and there's a Magic Leap team at Weta who have been making the first major game for the Magic Leap. And so in Wellington, you've got more access to working on Magic Leap than most other places. I have master students completing at the moment, and hopefully I'll be having another meeting with them as they write up their final report, using the Magic Leap, which is an AR headset, so you see through it and you can see the world. And they're looking at training doctors on how to inject and anesthetize part of the brain in a neurosurgical operation where you inject in beside the eye and the needle goes up into the brain, and then you kind of you take the needle and you inject into the part of the frontal cortex. So it's a sphenoblock procedure. And so they're wanting to train people on this without them having to actually use real human heads to do the procedure. And so my master's students in Norway were working using the Magic Leap and the devices and a virtual skull to train people on this particular medical procedure. And that's the sort of thing AR is being used for. Now for them, the virtual skull appears in the real world. As you inject in, you are holding the real device, and we're tracking that device so that although you hold the handle of it, the needle goes into the skull rather than just into space, right? So you see it going into a skull, but you're not actually using a real human skull. So that's the kind of thing that AR is being used for. You can see, and if I get this, and hopefully that works. This was a YouTube video, which you guys can watch on your own as well, which is, and I don't know if that's displaying. Is it displaying? Nope, it's not displaying in Firefox.
Okay, so you've seen the movies like Minority Report and Iron Man where they use their computer in the space around them.
Stop that. And where are we here? Nope, it's going to try and open it up there. So I'll go copy, and I'll go here, and you guys can watch that. Well, I can probably get it up. I just need to add a new window capture, and Firefox VR, and go add window capture, and okay. Okay, right. So if I just press play on that.
Okay, so you've seen the movies like Minority Report and Iron Man where they use their computer in the space around them. But how would you actually use that in your house or office today using existing technology? These movie interfaces are really great because they make something seem more powerful or intelligent for storytelling in the film, besides being nice eye candy. But if you're going to use one in real life, you probably don't want lots of little animated text and graphs. What you would want is something clear and easy to use. So I did a manifesto video before about VR, UI, UX, R&D. The gist was that we're humans and we can use our instincts to our advantage when we're making this new thing. This new thing being some kind of operating system environment with multiple applications, but around you instead of 2D like your computer or smartphone or kiosks. This video is a summary of some of those more useful workflows I've found in the last few months, partly for the uni, but also for the VR community. So I'm using this mouse to scroll through my presentation, and the numbers you see sometimes in the corner are citation references, and I'll try to keep it under 20 minutes. Of course, real life like this is a 3D interface, and we can look at information design in the real world or our interactions there. But to do this kind of full digital interface, we'll use a head-mounted display. So if you're even watching something like this, you probably already know that it's like headphones for your eyes.
So what I'll do is
environment you're in, and you can affect the world around you using that. You can also move yourself that way. Speaking of which, there's teleportation where you can jump from one place to the next. You can do the cursor thing for menus in space or radial menus. Samsung also had some useful numbers on depth. If something's past 20 meters, you don't really see. Say is the curiosity zone, where they've got to literally turn their body to see.
Yeah, so this is a 20-minute video. I'll let you watch it in your own time, or 18-minute video, because you can. The point is here is this guy is talking about his experiments and what user interfaces look like in VR.
And then outside of all this, you get to a point where the two views pretty much are rendering the same thing pixel for pixel. It's basically monoscopic and should probably just be part of the skybox at that distance. This gets further and further.
So that's a very useful video for you to look at to understand more about how designing for VR as an interface is an interesting activity. Okay, the last thing I was going to talk about, and I'll go back to that, and I'll just go back and turn off that one and go back to there. Right, the last thing I was going to talk about was actually the work that I've been doing stop that, go back here, go there, right, is actually thinking about, what is this VR world good for? What should we be doing in VR rather than what can we do in VR, right? Because we can do a lot of things, but what should we do, right? So when do we need immersion, right? Now, I've been giving some lectures in VR back to Norway. It's fun. It's kind of cool. That whole Oasis thing is neat, but for most of what you're learning, most of what you do in your degree, you don't need to feel like you're in a room with me. In fact, for a lot of lectures, this might actually be an acceptable interface for a bunch of students where they can see me, I can gesticulate, I can kind of get enthusiastic, and I can talk to you guys, and you can read the material, and you can see me, and it's okay. Maybe you could be sitting having coffee, or you'd be lying in bed and think, oh, I'll just pop into the lecture and see what Simon's talking about today. That might be better than having to put on a VR headset and feel like you're in a room with me. So, do you need it for learning? Most of the time, I'd say no, you don't need it. But it is very useful, and you're trying to learn something, say, for example, in a very stressful environment. So one of the things we are working with is the police college in Wellington are looking at how they train police officers in stressful environments. Now, if I give you a standard lecture like this about how to respond to someone when they're coming at you with a knife, okay? At the moment, most of you are sitting down and you're relatively calm. You don't have a lot of adrenaline. You don't have a lot of cortisol pounding through your system. And so what I teach you now is actually going to be much harder to recall if your psychological state changes. So I don't know if you were given this advice as students, but if you study and drink a lot of coffee when you're studying, when you sit that exam, you should also drink a lot of coffee so that you get to the same mental state you're in when you encoded information. And the same is true for stressful environments. If you learn something in a stressful environment, when you get stressed, you're more likely to remember it. If you learn something in a calm environment and you have to remember it in a very stressful environment, because your brain state is very different, it's much harder to access that information. And so what is a better way of teaching people on how to respond in a stressful environment is to put them in a stressful environment and then train those responses. And so what we're looking for in VR is to say, okay, can we use VR to train you to respond accurately and appropriately when someone's coming at you with a knife, or there's a psych patient who is escalating and starting to ramp up and they're about to become violent? Can we train you how to talk those people down when you're stressed rather than when you're calm? The other areas we might need it is entertainment. So, it's fun to feel like you're inside the video game. Or where feeling connected to someone is actually part of the experience, feeling like you are with that person. And so there's various things around tourism. Virtual tourism might need that sense of being there to be more engaging and awe-inspiring. We always have to think with VR and AR and any of these new techs, and any of using YouTube and videos, is this technology seeking a problem? Have we got this cool, fun VR stuff and we're saying, hey, it'd be great to do it for my students in lectures because that'll be awesome. And the students are going, why? I don't need you in the room with me, Simon. Just, help me understand stuff. Answer my questions when I need them answered. Are we responding to a demand, or are we trying to create a demand in the audience? Hopefully, are you back again? Anyway, so is this is this tech looking for a solution, or is this a problem that we are solving? Now, my teaching environment, some of the lessons I've learned from VR teaching, some of the interface issues are really interesting, because when you're looking at a screen, you don't know who's paying attention to whom. If you've ever done like a multi-part Zoom or many people in a Skype call together, you don't know who's talking, you don't know who's grouped together, you don't know who's talking to who, and it's all just a mishmash of talking, and there are no social cues around how to communicate. One of the things I could show you in VR is that when you're in a collaborative VR space, I can use social cues, and that's great. However, that's only useful into groups up to about 8 to 10. More than that, you might as well be a lecture theatre, and you don't need to be in VR, you just need to be watching the action. One of the other problems of getting you as students to put on a headset and be in the VR environment with me is that most of you use your phones and do other things in parallel. You often have divided attention. Divided attention is a problem because in VR, I get 100% of your attention. All you're doing is focusing on me in the virtual space. And so I have to have a much higher quality of lecture. I have to have something that's really engaging and very relevant. And if I don't, you cross that barrier of taking the headset off to go and do something. And once you take the headset off, then I lose you for a long chunk of time, right? So there's the nature of teaching needs to change when you do it in VR. The way I would teach you here is different when I'm teaching in VR, rather than teaching remotely like this or teaching from within the classroom. And that whole concept of only doing one thing at a time is a challenge for VR education. So the takeaways, and so there's a few takeaways here. One is, if you're interested in VR and interfaces, Kieran Carnegie's research is active. He's doing it currently. We're working with him. That's something you should go and look at. Go and look at the link I gave you to the interfaces in VR and understand some of those complexities around that. And there are lots of pros and cons about the way we do lecturing. This lecture, you can reflect on how much better or worse it is than actually having me in the room, having me give you a YouTube lecture. Now, I've seen a couple of comments come through in Discord, but you guys haven't been particularly active in asking me questions on Discord. But before I go, are there any questions? We've got another 5 minutes before I actually need to vacate the lecture. Have you got any questions about VR? And I suppose, how many of you would be interested in coming and trying the VR that's set up in my office once I'm back in town from Tuesday next week? Because of course Monday's Queen's birthday weekend, so there's nothing there. I'm giving a lecture on Tuesday. The dot voting is still up if you want to vote on a new lecture. Otherwise, you'll get whatever's in the schedule. But unless you've tried VR, it's actually very hard to understand how engaging it is. And so it would, if you want to come and try my teaching environment, I recommend that you come to my office sometime on Tuesday, where I'll be in the office, and you can experiment in VR, and we can talk about some of the VR and AR stuff we are doing. Okay, so are there any questions? Can people ask questions in Discord? Either audio questions or type questions. I see someone's typing. That's a good start. Of course, I could also check the YouTube video to see if the YouTube video is. I have to find where I put the YouTube. Is anyone commenting on the YouTube video? Okay. No, I think Discord's the easy way. Is there any research with VR and Google Maps? So, VR and Google Maps, good question, excellent question. So you're thinking, so that question is there any research on VR in Google Maps? So Google Earth in VR is fantastic. So if you want to come and play with Google Earth, we can put you in Google Earth. You can travel around the world, all over the world, in Google Earth and see the world. If you're interested in Google Maps navigation aspects, so one of the things that Google is doing is actually also looking at how they do AR and Google, right? So we have that in my office. So Google Earth VR is available in the machine in my office, and I have it on here. It is fantastic. You should certainly come and play with it. It's amazing to put yourself, particularly with some of the big cities internationally, where they've done the full mapping of them. You can actually put yourself in the city, and it's fantastic. It feels great. Google is looking at how they do augmented reality navigation. Okay, so you'll see me on Tuesday to come and play with Google Earth. Okay, so we'll definitely have a Google Earth session on Tuesday. So come, I'll be in the office from about 8:30 in the morning. So come and see me from 8:30 in the morning, and that'll be great, and we can take you through the Google Earth experience. Okay, any other questions? It's interesting waiting for questions. I can see someone's typing. What are they asking? Oh, they've gone away. Okay, someone was going to ask a question that decided not to. Okay, so go and have a look at the interfaces that this guy prototyped on that YouTube video on the UI interactions. He goes over a lot of the interesting research and the issues around it. That is his thoughts around VR interfaces and some of the experiments that he's done. So that's quite a nice place to look if you're interested in designing VR interfaces. If we can, what we'll do is I will try and bring in the VR again on Tuesday morning, just so a Tuesday lecture, so you can see it at the beginning, and I can show it off from about 3 and show you what we do. Otherwise, I will let you guys all go. Hopefully that was, I'm sorry about the impromptu Wellington weather destroying my opportunity to come and be there with you. Not much I could do about it, but hopefully this was at least a very impromptu solution to a problem of not being there. Okay, so have a good time, and I will see you all on Tuesday. Okay. Bye, guys.